Welcome, my dear students. We are going to study Werner's coordination theory. Jorgensen tried to methodize much of the information available in coordination compounds. He tried to formulate the complex compound like platinum Cl2 4NH3 by analogy to organic compounds as platinum it is attached to NH3 Then his chain theory was finally proved wrong. However, his chain theory was finally proved wrong. Platinum, it is a divalent and it is attached to the NH3Cl. This field was changed practically overnight by the genius of Alfred Werner, who introduced his theory of coordination compounds, for which he received the Nobel Prize for Chemistry in 1930. Practically all of Werner's ideas have been proved to be correct. The fundamental postulates or patterns which he proposed are still found to be valid. The nature of metal complexes was studied by Alfred Werner, a chemist from the Zurich, and he proposed the theory on coordination compounds. The postulates of Werner's coordination theory. Werner theory of coordination compounds. Each metal exhibits two types of valency: primary or ionizable valency, and second, auxiliary or non-ionizable valency. For example, copper NH3 4 in bracket SO4 tetramine copper 2 sulfate. Primary valency of copper is 2, whereas its secondary valency is 4. The primary valency of copper is its oxidation state, which is +2. Primary valency is satisfied by the negative ions. The valency of sulfate SO4 is 2-, that is the primary valence of copper is 2. Then the secondary valency is satisfied by the ligands by either negative ions. Neutral molecules are occasionally even by positive ions. Therefore, 4 ammonia molecules which are bonded to copper +2 ions, the number of ligands is 4, and 4 is the secondary valency of copper ions. The primary valencies are non-directional, but the secondary valencies are directional. Other examples: the hexamine cobalt 3 chloride. Primary valency is 3. It is due to the negative chloride ions, 3 negative chloride ions, and secondary valency is 6. It is due to the 6 neutral ammonia molecules. CO NH3 in bracket, then Cl3. Hexamine cobalt 3 chloride. Sometimes a negative ion may perform a dual function of satisfying both the type of valency. For example, CONH3 thrice Cl3 in bracket. The chloride ion satisfies the primary valency 3 as well as secondary valency 6 of the cobalt. Means 3 ammonia molecules and 3 Cl- ions. Total 6 are coordinated with the cobalt. These secondary valencies are directed in a space around the central metal ion. This postulate predicts the stereoisomerism of complex compounds. Secondary valencies are directed in a space. Means secondary valencies are directional, but primary valencies are non-directional. A metal possesses a fixed number of secondary valencies and is called as coordination number. The secondary valencies of a metal determines the geometry of a coordination compound. The secondary valency decides the coordination number. The combining power of metal is divided into a spheres of attraction, the inner or coordination sphere and the outer or ionization sphere. Neutron molecules are oppositely charged ions which satisfy the secondary valency of the metal are linked or the coordinated to this central in the coordination sphere, while the outer spheres contains the loosely held ionizable ions. Means the ionizable ions are outside the sphere, outside the bracket. To distinguish the two spheres of attraction, coordination spheres is included in a square bracket. On the basis of auxiliary valency theory, Werner formulated COCl3 6NH3 as CONH3 6 in bracket Cl3 and COCl3 5NH3 as CONH3 5Cl in bracket Cl2. In CONH3 6 in bracket Cl3 hexamine cobalt 3 chloride, coordination number of cobalt 3 is 6. The 6 ammonia molecules enclosed in square bracket satisfy the secondary valency, while the 3 chloride ions satisfy the primary valency of a cobalt ion. The addition of silver nitrate to the complex, the 3 chloride ions will precipitate as silver chloride. Outside the sphere there are the 3 chloride ions, and that 3 chloride ions are precipitated with the silver nitrate as silver chloride. In cobalt NH3 5Cl in bracket Cl2, chloropentamine cobalt 3 chloride, chloropentamine cobalt 3 chloride. The coordination number of cobalt 3 is 6. The 5NH3 molecule and 1 chloride ion enclosed in a square bracket satisfied the secondary valency of the cobalt 6. The 2 chloride ions which are outside the square bracket and 1 molecule ion which is in a square bracket satisfied the primary valency of a cobalt is 3. Therefore, 1 chloride ion does the dual function as it satisfied both primary and secondary valency. Inside the bracket Cl, outside the bracket Cl, then inside Cl and outside Cl2. 2 Cl inside Cl, 1, that is 3. Then the chloride ions, it does the dual function and it satisfied the primary and secondary valency. Since this chloride ion, Cl minus ion, is not ionic on addition of silver nitrate solution, only 2 chloride ions are precipitated as silver chloride. Outside the sphere, outside the square bracket, there are 2 chlorine ions. Only these 2 chlorine ions are precipitated as a silver chloride with the silver nitrate. Thank you.